So hello, everyone. Thanks a lot for coming to this panel, especially at this very late hour. So I hope that you enjoyed the first day of microXchg so far and enjoyed the talks, the conversations, the foods and the drinks. And so that you can now lean back, relax, and listen to this panel. So at this panel, we would like to talk about the state of microservices today and address the question whether the hype of microservices have been over now and if microservices have become mature now. So, and also what might be the future of microservices look like. So before we start the panel, I am very pleased and very honored to introduce this panel to you. And so we have Bryant on the right. He's from London, UK. And he's an independent tech consultant and writes for InfoQ, O'Reilly, and Voxed. And he frequently speaks at international conferences such as OSCON, QCon, and Java 1. And he's currently writing a book about continuous delivery in Java, which will be published soon at O'Reilly.
Soon.
Soon, exactly. So, and he gives a talk tomorrow about what is a service mesh and do I need one when developing microservices. To Daniel's left, there is Elisabeth Engel. She is from Munich, Germany, and she has a background of media informatics. She is a UX and software engineer at Gute Frage, and that's a Q&A platform in Germany about a wide variety of topics, like travel, finance, and health, and sport, with approximately 20 million users per month. And she gave a talk today about how to break up with your front-end monoliths. So to Elisabeth's left, we have Chris Richardson. He's from Oakland, California. He is the author of Pojo in Action, and he's currently writing a book, Microservices Pattern, which will be available or is available as a MEEP, or Manning Early Access Program. And he provides microservices consulting and training around the world, and he speaks frequently also at international conferences. He's the founder of the originally Cloud Foundry, that's an early Java platform as a service from Amazon AC2, the founder of Eventuate, an application platform for developing microservices. And Chris talked today about managing data consistency in a microservice architecture using Sagas. And we also have Stefan Tilkov. He's the co-founder and principal consultant at InfoQ. That's an IT consultancy providing software architecture consulting and development and training services. And he has written numerous articles and also a book, REST and HTTP, which was published in German. And he's a very frequent speaker at international conferences too, and he talked today about microservices patterns and anti-patterns. So thank you for being here, and just let's welcome us with a warm round of applause, please. So microservices come with a lot of complexities, and which requires different skills and also different tools and a cultural shift towards a DevOps culture. So there seems to be a lot of things which have to be done, especially at the very beginning. And as an organization which would like to introduce microservices, they might ask themselves the question, so when I am ready for microservices, what are the prerequisites for introducing microservices? And this question I would like to address to you, to the panel. So, Daniel, would you like to start answering this question?
Yeah, sure thing. So I think the key thing is definitely have a look at the current literature. So Martin Fowler in particular has got some great stuff around microservice prerequisites. Little or lesser known is Phil Calzado's stuff. Phil Calzado's talked about, I think, 7 prerequisites for microservices. So he extends Martin's original 3. So technically, those 2 things are awesome for actually understanding what are microservices, what do I need to have in the organization to get involved with them. But one of the big things I want to chuck out early, and it's something Stefan actually sort of hinted at in his talk earlier on, is understanding your domain model. I think if you're a startup company that doesn't really have product market fit yet, you don't really know kind of what you're building, I would choose whatever is best for me to learn the fastest. And often that is not microservices due to all the things Susanne mentioned in terms of the baggage that kind of goes with them. So I think that's my starter for 10 on that one.
If I might continue, I would say if you have pain, so you would only go to a doctor if you have pain. If you don't have pain, you don't go. And I think that's the same with microservices.
Yeah, I mean, sort of expanding on that, I mean, the whole, like any sort of tool in a sense, I mean, the purpose of the microservice architecture is to solve a problem, right? And so, at least from my perspective, I mean, the primary benefit of using the microservice architecture is to accelerate development. Or to put it another way, enable DevOps or continuous delivery deployment for large, complex applications. You know, the idea of being able to push into production many times a day, lead time of under an hour and so on, and also to be able to do it safely, reliably. So, you know, if that's not a requirement and you're happy deploying into production every 6 months, which interestingly, there are organizations like that, right? You know, you're in a domain where there's no competitive pressure, or you have a monolith and you're happy with the velocity of development. I'm sure the folks at Blockbuster were happy with the rate of development too. You know, but seriously, I mean, you can develop certain monolithic applications fast enough to meet your business needs. And if that's the case, you don't need a microservice architecture. But if you're frustrated with the pace of development and you have tried everything else, you know, such as you have automated testing as much as possible and you have the right level of maturity around your development processes, and you really, and at some point you will find that it's your architecture that's holding you back in terms of deployability and testability and so on. And that is an excellent time to consider migrating to the microservice architecture.
Yeah, I think I agree with basically everything that's been said so far. I think the critical thing is to know why you're doing this, and if the only reason you're doing this is because you were at this conference, that's not a very good reason. So there really should be some goal, some reason for you why you're doing this, and it could be one of those that were mentioned. It could also be that you want to experiment, that you want to try something out, and you want to have these islands of isolation that allow you to do that without affecting other stuff. But again, it's not a prerequisite. You can build awesome systems without microservices, and you can build cool monoliths. Sometimes you can build better software using monoliths than microservices. And what exact prerequisites you need very much depends on the variant, on the kind of microservice that you use, which can be very different. So, yeah, basically yes to whatever the other said.
Great. So, so introducing microservices is not a straightforward process at all. So usually it's so what we have experienced as from a startup perspective, it's a path with a lot of detours and failure along the way. So my question is, in your opinion, so what are the biggest barriers for microservices adoption and how to overcome them? Stefan, would you like to answer this question first?
Yeah. So I think one of the major boundaries is that it's so bad if you get them wrong and it hurts so much. So you tend to accept something that's not that great. Just because it's so hard to change, you start, and at the beginning everything feels nice, and at some point in time, you're faced with a lot of complexity, and then you have to make up your mind whether you really want to go back and question all of the decisions that you made in the past and really do that, or just accept it as the next level of legacy, which seems really weird. We're talking about microservice legacy, but there definitely is some of that already. So. That, I think, is something that you have to be aware of. You have to keep an open mind, and you have to be able and willing to change your opinion again and to refactor stuff and structure things differently and not do things the way that seemed the great, perfect solution at the very beginning.
Chris, would you like to answer?
Yeah, I mean, certainly, I think, the essential problem that you have to solve with adopting microservices is decomposing into a meaningful set of services, right? So it's sort of like, which is it's basically what software architecture, software design is all about, coming up with the right module structure so that your modules are, highly cohesive, loosely coupled, and so on. But there is this price where if you get it wrong, you're making a mistake at an architectural level, rather than just, I just messed up this module and I'll fix it. So you've made kind of a big mistake, and people do that. But the nice thing about, if you've got a monolith, you're incrementally refactoring into a microservice architecture. So it is this step-by-step thing anyway, which can help. And then one last point is, I think a big challenge is not embracing DevOps at the same time. So it's like you've got this cool whiz-bang microservice architecture, but if you're still developing using a waterfall approach with no automated testing, that's like buying a Ferrari and then having it pulled by a horse, basically. It's weird. Oh.
From my point of view, I think the complexity is the most hard part. So some years ago, maybe you had Java, and they told you if you have Java, you have a problem, and then you have a problem impl. But it still feels like manageable. And now you're in need, and you get a rescue ship full of containers. I'm not sure that helps if they are all full of other problems. So I think if we can find a way as for the developers to have something that you can easily understand, that you look at and understand, I think that's the key to what we should aim for.
Well, I just want to add to that. Don't mean to interrupt you, Daniel. But on the one hand, if you think about you're working on a massive multi-million line monolith. As a developer, you are confronted with that complexity every day, right? So that's kind of like the context. So if you're a developer of a service, you have an API that you have to implement, APIs that you have to consume. Your world is way simpler. And I think we need to remember that, even though we talk about they're complex and so on, at some level, the day-to-day experience of a developer is way better than dealing with some massive, complex monolith.
Yeah, it's a fair point. I think all those answers were excellent. A couple of just extra things I'll put on top, I guess, really, is don't forget about the technology attractions. I'm sure many of us in the room get a bit starry-eyed sometimes. Docker, Kafka, yeah, all this stuff that comes with microservices. So take care with that. I've definitely seen some self-imposed constraints with that. And the same thing with the actual process associated. The architecture is super important. It's what microservices kind of is, an architecture pattern. But the way you get together and design the system, the way you build things, is just as important as the actual architecture itself. So Pinny did a great talk today. Don't know if anyone saw Pinny's talk that talked about cloud native transformations. He had a bunch of awesome resources about how to put the people together in the most effective way. So I think look at that kind of thing as well. It's just a sort of the icing on the cake here.
Great. So one indicator of a technology becoming mature is when you can derive patterns and anti-patterns. Stefan, you talked about today about microservices, patterns, and anti-patterns. So what are the common pitfalls or anti-patterns introducing microservices?
So I don't want to enumerate all of them. I think I want to tie this to what Chris said, which I really think is a very important insight. With every architectural paradigm shift, the important thing is always this sizing stuff. It's always the same thing. It used to be the thing with objects, with components, with SOA services, with microservices, always the same thing. So I think many of the challenges are tied to coming up with the right size for things. Because if you have very, very small things and you have a lot of them, and that might be a problem. If you have very big things, you have only very few of them, and maybe that might be a problem. So getting things to the right size is like the holy grail of the whole thing. It has been like that for 45 or 50 years. There are old papers, like the original Parnas paper is from 1970 or something. 73. So it's still absolutely valid today, and that many of the things are tied to that. And you could essentially take much of what I did in my talk today and just use it like with a time machine, like 10 years ago or 10 years from now, it'll still be the same talk. I just replace microservice with something else because many of those things are similar. I think some other things are related to other also well-known insights that have been known for a long time. The often mentioned Conway's law kind of thing, right? The relationship between architecture and organization, and you can extend it to process and business and stakeholder relationships and all that stuff. If you just apply the technology, if you just look at a cool open source library that'll give you a dynamic registry lookup to find the right service instance, that's not going to solve a business problem on its own. And it's not going to solve anything if you don't have a relationship between what you're trying to do in the organization and the business side of things. So I think misaligning or failing to align business things with the microservice or with the technical approach has also been a problem for a long time, and is also a problem here. So that's maybe my favorite anti-pattern is this decoupling illusion, is what I like to call it, which is the idea that once you've built those tons of little microservices, everything's going to be good, and then you discover that any meaningful change requires changes to a number of them. So you now have a bigger problem than you had before, because you now have to release several things at the same time with a new version of something, or you have to deal with the complexity of incompatible or somewhat compatible versions of things. All of those problems you wouldn't have if you had sticked with the monolith. So this, I think, is an effect of having the wrong size of things, or the wrong carving up or slicing up of things. And I think that is the hardest part to get right. And so this illusion of having decoupling when you actually don't is my favorite anti-pattern. Mm-hmm. My least favorite.
Mm-hmm. So, but after you talk, I noticed a little tense Chris Richardson.
There is nothing wrong with an order service.
So a little tense Chris Richardson when defining entity service as an anti-pattern. So Chris, so what is your opinion about this?
No.
Second mic,
Oh, I don't know. What's the question here?
So what is your opinion about defining an entity service as an anti-pattern? Because I noticed that you felt a little...
Yeah, I did. I mean, this was the second conference in a row that I've been to where someone, by name, attacked my order service.
It's like to Chris's order.
Yes. Well, no, I mean... I think at some level, I mean, the one anti-pattern I've seen, I suppose I would call it a data service, right? Mm-hmm. So that is basically a service that implements sort of CRUD, and it's fundamentally a wrapper around a database. And to me, that services like that do not add any value, right? Like a service should be, kind of like a class should have meaningful behavior, and as well as its own internal data that's encapsulated by an API. So it's sort of more like I have no objections to your anemic service, right? Because I think to me that's one sort of a true anti-pattern, and then the other one is perhaps when you have these giant entity classes, like, I think practically every monolithic system of any age I've worked on has had like some table that has 300, 400 columns. There's always some, quote, God class that's the essence of the system. And there was even one client I talked to, they had exceeded the table limit of like their database. And so they had to have like an extra table with more columns. So that to me is and that ties back into DDD and decompose, splitting up these entities by bounded context and so on. So that to me is the kind of the essence of the problem that this sort of entity service anti-pattern is getting at. So I don't know if I answered your question, but...
That's totally fine. So,
sorry, let me just add, I 100% agree with that. That's exactly the kind of thing I wanted to criticize. I mean, there can be meaningful things that are composed around the concept of an entity, and if it's a useful, usable, meaningful service, I don't have any objections at all if it manages entities. I just have objections if it becomes too wide, if it has like 400 columns, or if it's just a data service, then I think it's an edit pattern. So we agree.
Yeah.
How boring.
Okay. So let's stay with data management. So one of the biggest challenges in microservices is how to handle the data, especially shared data. So Chris, you talked today about managing data consistency in a microservice architecture using Starkers. So what, in your opinion, how has data management changed in a microservice system, and what to consider when sharing data between the services?
Well, this kind of comes up a lot. Like, someone will ask me, well, what about reference data? You know, very truly static data. And I sort of have a bunch of answers to that. Well, sometimes you could just package up the data in a file and just access it, like a list of countries, for instance. Countries don't change that often, right? So that could just be static data packaged up as a jar file that's used, right? Maybe you could replicate data in each one of these services, or heaven forbid, you could have some shared database for some of this reference data. You know, at some level, no one will die as a result of that, right? Because the essence of the problem that you run into is when it's, if you ever need to change the schema for that table, and you've got 20 different Scrum teams owning services that access that table, then scheduling that schema change is likely to take a while, right? So it's like, given that the whole point of the microservice architecture is to be able to move fast, whenever you share tables, you run that risk of not being able to move quickly. But if it's purely static, then sure, but be aware that you might have just sort of shot yourself in the foot, or will one day, right? So.
Can I just add to that, Chris? One thing you mentioned there, I think super interesting. It took me a while to actually catch this one. Is that you're creating schema in a lot of places potentially. So in APIs is the obvious schema, and in databases and so forth. And there is some technologies you can use to kind of mitigate some of those risks. So I've used things like Pact and Spring Cloud Contract for consumer-driven contracts, and I've done some stuff with Avro and Thrift and a bunch of other schema validations even at the database level. They all come with trade-offs, so sometimes they're quite painful to use. But if you really do need to share something but enforce the contract, they can be nice technologies as well to use.
Oh yeah, absolutely. I sort of put those in the category of consumer-driven contract testing frameworks, right? And I'm actually a huge fan of Spring Cloud Contract for just that purpose. I write about it at great length in my book. I have an 83-page chapter on testing that I have to shrink down somehow.
So one of the things that we like to do in discussions and projects is that we actually show a hierarchy or a stack of integration options for sharing data, right? And some of them have been mentioned, like having some, like a file that's just rsync to different places, which is a pretty static but very useful approach. There is also something even below that, which is like, for example, sharing a module in your configuration management tool of choice, like having a Git module that you, or a subversion sub-project or a module that you just grab from. So that's very, very static. It's not at all dynamic, but sometimes that's perfectly fine. And there are other things like merging stuff together at the very last possible moment on the server side with edge side includes or server side includes, stuff like that, or aggregating the client. The point I'm trying to get across is that there are so many options, and the point is not that any of them is the right one. It's rather that whatever your needs are tells you what options make sense in this particular case. So anytime somebody tells you this is the only way you can do it and this is one thing that you can never do, that's most probably wrong.
Okay, so not only data is very challenging, but also our front end, also our user interface. So Elisabeth, you talked today about break up with your front end monoliths. So can you give some advice what to consider from the front end side when introducing microservices?
Yeah, so I think most is done in the back end, and then when you come to the front end, you've mainly two I would say, obstacles. So the one thing is the user will assume this is one thing. I think you don't have that in the back end, some API that assumes everything is the same and look the same, and you have so much shared stuff. So you have to somehow make sure for the user it stays consistent. So what most are doing is that they somehow share a header and a footer. So you always have this feeling of context that stays with you, and just the content is switching. And the second problem is how this content is switching, because front-end technology was never built for that. So HTML, CSS, JavaScript, nothing is built to have this micro front ends that will come and go and not conflict. So you have like this very old solutions of frame sets and iframes where you try to have this sandbox, but they come with so much more disadvantages that there's a need for something to have, and this will of course rely on JavaScript and a bit of working around to get this reloading of content, and I think there are some really nice approaches to do that.
Great. Any other comments?
Yeah, I think this is one of the things where back-end architects, and I include myself in that group, really need to get off their high horse and recognize that front-end stuff matters. Typically, it matters way more than the boring back-end stuff that we're also proud of. I really think this is undervalued skill, and many people don't. Many people think this is just, somebody will make it pretty afterwards. It's just, we're building these awesome backend services and everything's going to be great, and that's just not true. Awesome backend services say nothing about the quality of your application. You can build horrible applications based on presumably great backend services. And so I think those approaches, like trying to come up with new and innovative ways of modularizing the front end, is the most important area of research right now. So cool that you're doing something there.
So you know that at least 5 JavaScript front-end frameworks were invented while you were speaking.
Yeah, and all of them have the assumption that they're going to be the only one.
I actually long for the days where it was like HTML with a sprinkling of jQuery. I mean, there was there was even older frameworks than that. I mean, like, I talked with some folks today, and their architecture was, their services generated HTML fragments that were then assembled into a page by server-side include technology. So there's sort of there's a couple, because to go back to the other question about patterns, right? I mean, there's sort of kind of 2 places where you can sort of assemble the UI, and one part is server-side with, say, server-side includes, and then the other aspect or other way of doing it is client-side kind of assembly of page fragments, and they're different but kind of equivalent.
I think it's the same as in backends. At some point you have to orchestrate stuff, and then it gets difficult because you now have a central station, and every developer will love to put it in there because there's everything available. And I think it's the same also in the front end. If you have some server-side includes, you will have one page that combines the stuff, and if you now want to introduce something, this was be the most easy point to introduce it, but then you have the complexity again. So you start to build another monolith that is just think of composing, but then, so I think it's the same temptation as also in the back end.
Yeah, I agree, but that's actually, I agree with that, but it's true in every layer, right? So it's true in the single page app that tends to become the modern front-end monolith, and I think I completely support the idea that most apps should not be single page apps. Most of the time that's the wrong decision, completely convinced of that. But sometimes it's not. Sometimes it's a great decision. And the same is true for server-side includes as well. Sometimes that's exactly what you need. Sometimes it's plain stupid. Nothing can be a good decision without taking context into consideration. So.
Can I just add one final point? It was a really good talk that helped me think about some of this stuff, even though I'm mainly a back-end developer. Actually, yourself, Stefan, talked about, is it Otto DE? You talked about using transclusions, both like Angular, NG transclusions, and also server-side stuff. And that, when I work with various clients, a lot of them haven't heard of the concept of transclusion. So when Stefan mentioned that, like a couple of years ago here or somewhere, I went away and learned about that stuff, and I find that really helpful in pushing people often the other way. We're going to transclude the whole page to build it up, and then they kind of snap back at a more meaningful kind of area as well. So that was a good talk. I think it was here 2 years ago, maybe, or.
Yeah, it was actually. It's evolved since then. So if any of you are interested in that, just come to me, see me sometime afterwards, today or tomorrow, and I can show you some demo that colleagues of mine have built since then. So, yeah.
Cool. So. Let's now reflect, after we have now covered like data, front end, anti-patterns, let's now reflect service-to-service communication. So Daniel, you are going to speak tomorrow about service meshes. And can you give a sneak preview of your talk about how can service meshes help us in the microservices world? And give us first a brief overview what service meshes are.
Oh, there's a lot there, Susan, to unpack. So I'm going to talk about sort of the bit of the history. So as a heads up, it is going to be a high-level talk. I'm not going to do any demos of Istio and stuff, because my demos are always really bad, my live demos. But I'm going to introduce some of the theory, touching on some of the stuff that Stefan actually talks about today in terms of a lot of the ideas of service meshes have come out from the likes of Netflix and Google and so forth. And we are not all Netflix or Google, so we've kind of got to bear those things in mind. But service meshes are looking to kind of homogenize a lot of the common patterns and problems we see with service-to-service comms. And I'm talking about things like dynamic routing. So if you're deploying, say, containers, the IP addresses may change, the routes may change, and a lot of the technology we have at the moment finds it hard to keep up with the changing routes. Things like fault tolerance and also observability are a little bit challenging in the microservices world in regards to RPC. So you could argue that service meshes are kind of the missing layer in something like Kubernetes. Kubernetes is amazing at handling all the deployment. We give it a descriptor, and it makes sure our state of the world matches what we declare in our Kubernetes YAML. But some of the communication hasn't really been addressed yet. So you've got the deployment, the kind of, you could argue almost the static kind of snapshot of how our world should be, but our runtime model, our kind of dynamic model of how the services are interacting, we haven't put a lot of attention on yet. So service meshes are something that is trying to address that. I'm going to totally caveat the talk by saying it is kind of hipster tech. So Pini in his talk again today mentioned that service meshes arguably aren't ready for prime time yet. I've seen Linkerd in production, I've heard of Istio in production, but it's pretty hipster. And I would always, we've said it a few times already today, and I think it's a great statement, is do make sure you're solving a problem rather than just introducing a solution. So if you've actually got some pain, I mentioned, great time to think of, our service-to-service comms are kludgy, we can't understand our system, we can't observe our system, maybe have a look at service meshes. But if you're, you're using step functions, or you're orchestrating your flow of microservice data, or you're happy with your RPC, or your messaging, Kafka, maybe don't look at service meshes yet. I think they're going to be pushed into the fabric more as time progresses. So hopefully that addresses most of the things, Susan, I think.
Chris, do you want to add something?
Yeah, I mean, I think the idea of having this service mesh that sort of intercepts, mediates any inter-service communication or any communication from the outside in is a good thing, because sort of if you, in the absence of it, you end up having to have some kind of framework or library in each one of your services that implements this functionality. Like the classic approach is sort of with Netflix, right? Like the Netflix thing is, well, you need to do service discovery, therefore you must have the Eureka client, right? And and then, I need to do fault tolerance, so I have to have Hystrix at the circuit breaker. And at some level, there's like a laundry list of functions that you end up having a library for. And the fact that, say, you can use Netflix OSS in Java is good, but what if you're a Node developer or, heaven forbid, a Golang developer? That was a joke, by the way. You have to kind of get a library for each and every language and framework that you're using. And so the idea with like pushing those functions down into the infrastructure so that you as a developer just get this functionality for free is, to me, super compelling. And yeah, I think, say, Linkerd is production ready. Istio, the vision of that is fantastic, but you were there. It's not ready yet for prime time, right? But it will be one day, and it sort of shows the future, right? Which, as in like, a week from now or whenever, right? So it's a good thing. And it's not an ESB. There is no business logic in it. I should see, in case you want to make that comparison.
Yeah, I think I love the idea of having that kind of stuff outside of the business logic process, right? So it should be separate. I completely agree with that. And I would love for there to be a widely available, mature piece of infrastructure that does something like that. The problem is that every time you depend on something like that, you accept a dependency and you rely on that thing to be available. So you have to be aware of the risks and of the costs of doing that, right? So sometimes it's better to not rely on something and rather build yourself and own it and then be able to change it. Sometimes that's just a stupid idea because it's a waste of your time to build something that somebody else has built. And very often it's very hard to make that distinction in any particular case. So, but that's just architecture, right?
One thing I'd add on to that, Stefan, something that Pinny said today as well, is that often people push against some of the technology in the sort of hope of being vendor neutral or avoiding vendor lock-in, but ironically they become the only vendor. They build something themselves and they have to then support it, and if someone who's built it leaves the company, nightmare. So there's something to watch out for there as well. But I'm totally with you in terms of context is super, super important.
Yeah, I mean, at some level, anything that is not business logic and user experience is, I think, ultimately sort of, I mean, I wouldn't quite put it in the category of waste, but you have to think carefully about investing your time and money in developing things that give you no competitive advantage in the market.
Amazon people, Chris, call it undifferentiated heavy lifting.
Yes.
Super snappy, but that kind of makes sense.
That just rolls off the tongue. But yeah, I mean, you really need to avoid undifferentiated heavy lifting. I mean, because, sooner or later, it will just become commoditized and available as some library or a service, and you've just got this technical debt. And it doesn't get better by itself, unlike some, service or software that you bring in from the outside.
Okay, so thank you a lot. So I would like to address now a little general question to all of you. So, what's in your opinion? Have microservices emerged as the preferred way to create enterprise applications? Who would like to start?
Well, I mean, part of me just wants to say, no, they shouldn't be a preferred way, right? There's the monolith, there's, say, the microservice architecture, and which one you pick should depend on the context, right? So, if it's a team of 6 people, you're fine with a monolith almost always, right? Whereas if it's 10 teams of 6 people, there's a pretty good chance that you should be looking at some form of service decomposition. Perhaps, maybe even ideally, just one service per team, right? Facilitates team autonomy and fast, reliable delivery of software.
I think I agree with the feeling. It shouldn't be the default way or the preferred way, because that depends on context so much. And sometimes it's clearly not the preferred way, but often it is, and whatever we think, it has become the default way. So people build something based on a microservices architecture because that's just the thing to do. So deal with it.
I think a nice way is also to prepare for that. So when you start, that you know maybe it will grow. So I have like a point, if it breaks, it should break there. If I have that in mind, it might help to, when you start with a monolith and 6 people and then you grow and grow, that you already think of, okay, if I have to split up, I'll split up here, and I already prepare for that.
Yeah, I mean, there's this really interesting thing. It's sort of like in the beginning, you don't need it, like especially your startup example, right? But then the problem you have is by the time you do need it, you've got tangled dependencies, and migrating it can be challenging. I mean, so there is some concepts around building modular monoliths that can be valuable. I mean, another thing that's super interesting to consider is, well, imagine that you build your system out of event sourcing based DDD aggregates, right? That means you have a whole bunch of domain objects that are incredibly loosely coupled, right? They're actually communicating or collaborating via events, and they don't really care where they're located. So that, like event sourcing is fashionable. So that does give you a form of highly modular software.
I think generalizing on that one, Chris, as well a little bit more, and something Stefan mentioned in his talk, and I saw Neil Ford talk about it a couple of weeks ago in New York. This concept of evolutionary architecture, I think, is super interesting. And Neil Ford, Rebecca Parsons, and Pat Coar have written a book on O'Reilly called Evolutionary Architecture. And I was lucky enough to see Neil do a 3-hour workshop in New York. And he talked about a bunch of principles. Event-driven communication is actually one of those principles. But he also talked about a bunch of other tools, like things like Arch Unit and JDepend, where you can kind of codify some of the principles we agree as a team that we shouldn't violate, as in terms of complexity of classes, complexity of modules, complexity of microservices. It's turtles all the way down, as we say. And they were the principles. The book is really worth a read. It's an O'Reilly book. If you've got Safari, totally worth a read. They've done a really good job of capturing the zeitgeist of microservices, but without using that word too much. And there's a bunch of interesting tools you can put in sort of day one. There is obviously an overhead by putting some of those tools in, but if you know you're going to accelerate quite fast and you have already worked together as a team and you have certain principles you like, why not encode them in your build pipeline with some of these tools? So if you get a chance to look at Neil's stuff, it's super, super interesting.
Okay, thanks. So if we now look a little beyond microservices and address the serverless topic right now. I would like to combine 2 questions. So is serverless the next step to build systems? And the other question is, how will microservices and serverless work together? How will they collaborate with each other?
Oh, yeah, when I saw that on your list, that was, I mean, to me, serverless, I sort of view it as almost orthogonal to microservices, and from my perspective, serverless is a way of deploying microservices. So I don't sort of view it as the thing beyond the microservice architecture, but instead it's really like the thing beyond containers, which just so happens to be another way of deploying microservices. And so from my perspective, I mean, my sort of decision tree for deployment is, for my services, is serverless a good fit? If so, use it. Oh, well, I should use containers then. Or maybe then the fallback is like EC2, virtual machines, and so on. So that's my take on serverless versus microservices.
I agree with that assessment. I think it's the perfect deployment option. It's like you could call it a platform as a service offering, right? Clearly, 5 years from now, we're not going to deploy new Kubernetes clusters anymore. I hope nobody builds their career on doing that for years from now. I think that's something that needs to be commoditized, and it will be commoditized. But the problem that I have with this notion is that while I like the approach, I cannot, for the life of myself, figure out how I would build a large system just composed of a few hundred or a few thousand functions as the whole mechanism of structuring things. I just don't know how to do that. I think we need something that clusters them into larger units, and that's something that I find missing in that approach. The same way that I cannot imagine building a large-scale business application composed of database triggers that call stored procedures, I cannot imagine the same thing on AWS Lambda using tons of functions. That's not enough for me to structure a big application. It's still a worthwhile thing. It's nice to have the mic, actually. But it's still that's unfair. You cannot shout into this one. Right. So I think it's from a deployment perspective, it's awesome. I think you can do very cool stuff with it. I just have a problem to view it as the only thing that we'll use to build future systems.
Can I quickly check in, Chris, before you get in there as well, and just say that I think I was chatting to Chris earlier and someone else, maybe Thomas earlier, about this as well, is there is technologies popping up like Camunda we were talking about. So Camunda is kind of a next evolution of some of the BPM stuff, in that you can use DSLs to describe how functions interact. It's going for the holy grail of service reuse, because everyone's written a login service like 1 million times. Everyone's written a checkout service maybe 1 million times as well. Maybe not 1 million, but quite a lot. So having those kind of things being able to be composed into a business flow. Anyone who's used BPM and BPEL in the past, I'm sure it doesn't bring happy memories, but nonetheless, it is an interesting bit of tech. So I think maybe, Stefan, I don't think it's the answer. I kind of agree with you, to be honest, but I think maybe is a little bit of a hint of where it's going, in that there is going to be some class of business problem that's highly event-driven and very simple in nature, and therefore assembling these small components together in a workflow BPM-like fashion is going to add quite a lot of value quite quickly.
Yeah, I mean, what's interesting is if you look at the AWS documentation with, let's say, Lambda, it's like, I want to implement a REST endpoint, so I have a Lambda function to do that, and I'll package that Lambda function as a zip file. And so they promote this idea that you're building this very fine-grained system. But the other way of looking at it is, well, you have, like, say in a Spring application, you have, a REST endpoint that maps to a controller method that calls a bunch of business logic, right? So you just think of each Lambda as a request handler for a particular REST endpoint, and it's just packaged up with a whole bunch of other related Lambda functions into a single deployable zip file. So in reality, you're not actually building, from the perspective of a developer, you're not actually building a fine-grained system any differently than you would view a Spring application with a bunch of REST endpoints as being a fine-grained system. So that's my take on it. So there you go. Now you know how to build an app with thousands of little things.
Thank you.
I just check one thing, Chris sort of jogged my memory, is do be aware of the operational sort of characteristics of serverless. That is, in that context, Chris, in terms of, I've often seen people write really small functions to deal with business problems, but having like loads of config to set up the API gateway. So there's no ops, but you still have lots of configuration management. So I've worked with one team that were like, hey, I'm going to write these really simple lambdas with gateways, and they were like a couple of lines per function, but then we had probably like 20 times more config code in Terraform and Ansible to deploy the things. So.
Oh, God, yeah. I mean, the API gateway, I think it's got better. But, I mean, the docs were incomprehensible when it first came out. No, I actually used the serverless framework, as in serverless.com. And so it's like my Java lambdas, it's like a regular Gradle build file that has a task to build a zip file. And then there's a serverless.yaml that defines the mapping from Lambda, from REST resources to Lambda functions. And it generates all the ugly stuff to go configure the API gateway. And so you just go serverless deploy and wait a few minutes, and you've got a deployed application. So yeah, no Terraform, I love Terraform, but not for that.
Okay, so with the last question, let's play the devil's advocate of the future. So what is your opinion? So will microservices fade away and evolve into something else?
I think a lot of the ideas are here to stay. Like I think this idea of reducing the size of things, which to me is the key aspect of the whole idea, having these boundaries explicit and supported by physical aspects or virtualized physical aspects, is a very important part of the whole thing. And I think that ties so strongly into organization and process and the way we want to motivate people and incentivize things. This is something that's going to stay. I'm really, really confident about that. The technology will, of course, change a lot. And it has changed a lot as long as microservices have existed, right? They used to be like, you build an executable jar, and then everybody started to Dockerize everything, and now we're considering to serverlessify it, if that's a word. So the technology changes all the time, platforms change, implementation technology changes, but this key idea of having those boundaries, this inside-outside view of things, that I think is going to stay for a long, long time.
Mm-hmm. Any other comments?
Oh, yeah, I mean, I sort of think that, like, what is here to stay, right, is, say, DevOps, or, no longer is, like, annual, quarterly, or weekly releases good enough, right, for a lot of software. It's just constant, rapid, and safe delivery of software. So you need an architecture that facilitates that. And so, yeah, I mean, that's, I guess, to me, is sort of, an architecture that's comprised of loosely coupled yet and independently and easily testable components. And yeah, and it might evolve into some other form of services. But sort of like, who knows, right? Then obviously the trend on the deployment side has been from physical to virtual to containers to lambda-less, right? Which has been dramatic transformation. The sort of hardware folks have the benefit of Moore's law, right? They get exponential, whereas software developers, we just Google stuff. It's just sort of linear, slightly linear improvement in how we build software.
So I think we will always have this need of reducing complexity, and going to something micro is, I think, one direction to do that. But I think we will also come with other possibilities and solutions to what Stefan already mentioned, to have this size, so an appropriate size. So we came from this one monolith to 100 microservices, and maybe we find a pendulum in the middle to what fits us.
Yeah, I think the span of my 15-year career, the technology I've got available to me and we've all got available to us now is genuinely incredible. Like Amazon in particular, it's just amazing what you can spin up. And I think with the architecture patterns, with microservices, with event-driven, with serverless, all these good things, I actually think now there's other things that are bottlenecks, to be honest. I think that the architecture principles behind microservices, cohesion, coupling, separation of concerns, they're timeless principles. The Parnas paper is a classic, Stefan mentioned there. I actually think the technology has got to catch up a little bit in terms of a lot of what we've been doing recently is going to be pushed down into the platform. So like Chris mentioned, the libraries like Netflix and Hystrix and all these kind of things, I think they're going to be pushed down into things like service meshes. We're going to be doing some learning there. And I think one of the biggest challenges is sort of workflow orchestration. How we actually mash all these things together, I think, is still an area we're learning about. Serverless and microservices give us lots of tools, but I do think the business processes in relation to all that, who owns it, how we design it, is still quite new as well. So my gut feel is like microXchg in a couple of years' time might actually be looking at more the business side potentially, and how we kind of add value to end users, more so than perhaps Docker and Kubernetes. I've noticed that even as I've been coming here the last 3 years, there's less talks about Docker and Kubernetes now. There's more about mainstream architecture. And I wonder if 2 or 3 years' time, it might be more about where we invite our business colleagues to the conference. How cool would that be? Or maybe not cool, I don't know, but it could be interesting in that we need to mix up and let everyone else catch up with some of the cool things that we've got available to us now, I think.
Okay, so we have some time left for some questions from the audience. So do you have some questions? We have some questions.
Oh, many questions there.
From my experience, the biggest problem with microservices, with adopting microservices, is not correctly, let's say, adopted microservices, is not a size, because size is, from my point of view, is quite easy to understand, because basically size depends on, completely depends on size of bounded context. So what is the size of a microservice? Is the size of your bounded context behind. But the more, from my point of view, the more essential problem is understanding of developers, understanding DDD, domain-driven design by developers, because sometimes we can build a beautiful contract API for microservices, but behind is just a simple couple of stored procedures and no business logic. And the maintainability of such kind of approach is really difficult. My question is basically to Chris, how to persuade developers to embrace DDD approach? What do you think? Because otherwise, it easy to degrade to anemic services anti-pattern.
Yeah, well, I mean, this sort of goes back to the whole issue of modularity, right? Where you have to design modules that have an API that encapsulates a sort of significant amount of functionality so that you can change that sort of the implementation without having to regularly change the API in a breaking way, right? You know, I mean, that's true with modules, right? So it's skinny interface, sort of fat hidden implementation that you can work on, a different team can work on independently without causing breaking changes. And so that's sort of like, well, that's kind of an architecture thing, right? Like, you know, because it's the job of the architects to kind of try and enforce good boundaries between these services and make sure that they're not kind of like skinny services that don't have any, that just, where the API just exposes everything, because then that API will change constantly and trigger changes in the consumers.
So I think sometimes a lot of the things that we want to do rely on people wanting to do the right thing. Sometimes they don't. I mean, sometimes it's just a matter of education. Sometimes you have to convince people. Sometimes you have to give them good reason to do the thing that you consider to be the right thing, right? Maybe they just don't know about all the awesome benefits that your approach has. So talk about it and evangelize it and explain why it's great. And once they see that it's great, they will enjoy it and they will want to do it on their own, which is awesome, and that's the perfect world. Sometimes people don't want to do what you consider to do the right thing. So maybe you're wrong. That's one option. Or maybe they have different motivation. Maybe their motivation is not, as you would expect, to, you know, do something that generates business value. Maybe their motivation is to do something that doesn't cause any change in the way they do work. So it's very hard to give guidance on how to convince developers without knowing the individuals who do that. It's a human problem, and some people are not convincible, and that's okay. Then you have to, maybe look for a different job, either for yourself or for them. And if you can't do that, you have to maybe not do that thing. If it's so awesome, but nobody except you believes that, then maybe it's not the right architecture for the place you work at. Right? Sometimes that's tough, but it's the only thing you can derive from it.
Okay, so or do you want to allow another question?
Is anybody tired? Or shall we do another question? One was there. Okay. We can do one.
Okay, one last question from the audience.
Okay, yeah, thank you. I will try to make it short. I'm a huge fan of the technology agnostic aspect of the microservice architecture, and I myself are a PHP developer, and I work a lot with Java developers, and I feel a bit like we're at the current moment we're fans of two different sport clubs, and we're fighting each other. So now with the microservice strategy, I think we're coming to a point where we think, okay, we're now playing at the World Cup, and our players are on the same team. But now we're currently discovering, we are playing football, they are playing handball. So for instance, with Spring Cloud, it brings a lot of orchestration features with it, and Kubernetes brings a lot of orchestration features with it, and there are other things like Linkerd or Istio with another set of a lot of orchestration features. And my question is, do you think there will be some point where we'll have a standard for these different approaches for load balancing, for service discovery and configuration, where we'll have a common standard where we all can live happily together, play on the same field?
Oh, probably not. But it's sort of like, there's, once you've figured out the appropriate decomposition of your system, the other sort of critical kind of architecture decision you have to make is really sort of around what I'm calling this base architecture, which is you need to pick mechanisms for all of those different things, right? Like, say, service discovery. And so it's like, do you use what's built into Kubernetes if you're running Kubernetes, or do you ignore that and then you run, say, Netflix Eureka on it? And there's different trade-offs, and so someone has to make a decision on how to do service discovery, and then you all have to kind of live with the consequences of that decision. Personally, I prefer as much of that pushed into the infrastructure, so that Spring Cloud's great for wrapping Eureka, but you're on your own as a PHP developer, right? And so if you're just using Kubernetes level service discovery, you don't have that problem. And so infrastructure, service meshes, handling those concerns is sort of the way to go.
Can I just check on that, Chris, as well? I think one thing that I see in my consulting job, I was just mentioning just before this session, is that people often don't weigh up the skills of their team quite enough. So if my team I'm working with, say, are all Java developers, Java's my world, that's why I'm using that example, and we need to do service discovery, and we've got a fairly standard use case, Spring Cloud can be amazing. Spring Cloud lets me get going super fast. The semantics of Spring Cloud are very familiar to a Java developer, so often I'll say, check it on Amazon, go with that. But if we've got a team that is, say, are really good developers, but they're not operationally aware developers, they're not particularly operationally savvy, then I might sort of punt some of that responsibility into something like Kubernetes. I might have a really strong sysadmin on the team, for example. So do weigh up the makeup of your team and the specialities and the knowledge you have now, and also versus where you want to get to in the future. I think that's super important. And one other caveat onto that is some technologies you bring in, you will be massively penalized if you don't go the whole hog, as we say, the whole in. Kubernetes is kind of one of them. I think I've seen some people try to use Kubernetes purely, say, for orchestration and then do all the routing themselves. And it kind of feels like you're swimming against the tide. Yeah. In some ways, if you are going to embrace a technology like Kubernetes, let it do the scheduling, the routing, kind of everything with perhaps a service mesh or whatever. Same with Amazon. There's that delicate balance of if you're going to go with AWS, kind of embrace their stuff. Otherwise, you're going to be swimming against the current. So it's always a trade-off. Obviously, we keep saying that in terms of if you do try and create your own abstraction layer, you pay a cost. But some technologies, I think you're penalized more than others. And Kubernetes is a good example. I've seen literally people layer whole platforms on top of Kubernetes in the hope they're going to try and make it sort of make it more friendly for their developers. And in reality, I think a small education piece about Kubernetes would have been much more beneficial, to be honest. So maybe a lot of words there, but perhaps something to think about.
I'd just like to add a very minor thing, which is that I tend to advocate that you should pick some implementation technology that you hate, whatever it is, like maybe it's PHP or it's Perl or it's I don't know whatever it is, and validate all of your architectural decisions, your macro architectural decisions against the idea, can it be used with that technology? However unlikely it is, because that'll protect you from introducing all of those assumptions of how people implement things into your macro architecture, which I think is one of the things that Java people and Microsoft people and whoever is a part of a common ecosystem does. Way more than the PHP people, even though I'm not a PHP developer.
Okay, so we are definitely at the end of our panel. And I just have to say thanks a lot for attending this panel, and thanks a lot for coming to this panel.